Hi, we wait for 2 more minutes. Hi, shall we start? Hello.
Sir, nobody joined now.
No problem. Anyways.
Okay, start. Okay.
Mhm. Okay. So, uh, so yesterday we stopped with this sorting algorithm, and I told you we'll discuss about selection sort. So let us take that to the end of the session. Okay. First, let me complete today's session, and later we can see selection sort if there is time. Okay. So the first algorithm which you're going to see today is merge sort. So merge sort also comes under divide and conquer strategy. Okay. So it is actually a sorting algorithm. You will be given a set of elements in random order. You have to sort it in ascending order or descending order based on the requirement. Now let us see how to sort using merge sort in ascending order. So first let us see the illustration. Then you'll come back to the algorithm. So before that, for all divide and conquer strategies, the algorithm will have a principle. Okay, will have a principle. So the principle for merge sort is that if you give me an entire set of unsorted array, I would not be able to sort it. Instead, give me two sorted arrays. Okay, give me two sorted arrays. I will combine them. That is, I will merge them and give you a single sorted array. I will repeat again. If you give us entire sorted array, unsorted array, I would not be able to sort it. Instead, give me two sorted arrays. I would sort them and give you a combined sorted array. So this is what is the principle of merge sort. Okay. Now we have to identify when can we definitely say that the elements of an array are sorted. Yes, any answer for this? When can we definitely say that the elements of the array are sorted?
An adjacent element is greater than the compared element. Like total
Uh,
ascending order
Without doing any comparison.
without doing any comparison.
Yeah, based on the number of elements. Based on the number of elements. Okay. So if there is only one element in the array, can we definitely say that it is sorted?
Yes.
Okay. So whatever might be the sorting, ascending order or descending order, it is sorted if there is only one element, right? So that is what we're going to do. We're going to keep on splitting the given set of data, okay, given set of elements until we reach a single element array. Why? Because the requirement for merge sort is you need two unsorted array, sorry, two sorted arrays. Okay, fine. So let us see how this is working. Now, what we're going to do is, so this entire array, it cannot be solved by the merge sort. So what we're going to do, we're going to split it into two halves. Okay. So the splitting process is the same. L plus H divided by 2. You can get the midpoint. And then from the midpoint, the left half and the right half. Okay. So is this array sortable? There are three elements, right? So still we cannot solve this. So what we're going to do, we're going to further divide it. So if you further divide, you'll get 12 in the left side and we get 34 and 23 in the right side. See, all these are going to be recursive calls. Okay, so this is a main function in the sense like the first function call, merge sort function call. From that function call, we have two recursive calls. Okay, so data is being split into two, right? Left half and right half. The left recursive call and the right recursive call. From the left recursive call, again you have two more recursive calls. Okay, the left recursive call and the right recursive call. So is this solvable? There is only one element, right? So we can say that this array is sorted and then we can return that array. Understood? So for this array, we have a left array which is sorted. Now we have to sort this right array and send it back so that we get two sorted arrays. Okay, I'll explain it. Now we have this array. This array is still not solvable. Okay, because there are two elements. So further splitting, what do we get? We get 34 and 23. So the left hand side we have 34, right hand side we have 23. So now what happens? This recursive call, there is only one element. So it is sorted. So it'll return that this array is sorted. Understood? Now it comes to the right hand side. Here also there is only one element. So it'll return that it is sorted. So now with respect to this function, we have this two sorted arrays, right? One is 34, other is 23. Now what happens is these two will be passed to the merge function and then we will get a combined sorted array which is sorted. We'll discuss about the merge function after the illustration. Okay. Now with respect to this function, we have this sorted array and this will be returned to this recursive call. With respect to this recursive call, left hand side we have 12 which is a sorted array and right hand side we have another array which is 23 and 34 sorted array. So you have two sorted arrays. Okay, combine them, you will get 12, 23, 34. Understood? So this array would be returned to this first recursive call. And from here it comes to the right hand side. So this is still not solvable. So what happens? It gets split into 1, 5 and 45, 56. And this 1, 5 is still not solvable. So it'll get divided into 1 and 5. So this is a sorted array. This is a second sorted array. Combining them, we get a single sorted array which is 1, 5. So this will be returned to the previous function. Now comes the right hand side. 45 is still not solvable. Will get split into 45 and 56. So left single element, so sorted. Right single element, sorted. So we have two sorted arrays with respect to this function. This will be combined together to get 45, 56. Now with respect to this function, we have two sorted arrays. One is 1, 5, another is 45, 56. Combining them, we have 1, 5, 45, 56. This will be returned to this function call. Okay, this function. Now with respect to this function, we have two sorted arrays. One is 12, 23, 34. Other is 1, 5, 45, 56. So merging these two, we will get the overall sorted array, which is nothing but 1, 5, 12, 3, 34, 45, 56. So this is the overall picture of merge sort. Okay, the thing is you need to pass two sorted arrays to combine them and to formulate a single sorted array. Now let us see how this merge function is working. Okay, for the merge function, we need two arrays, array A. So let us take the same elements itself, 12, 23, 34, and array B, 1, 5, 45, and 56. And using these two arrays, we're going to create the overall sorted array, which is C. Okay. Now to iterate this array A, we have a separate index I, and to iterate over this array B, we have the separate index J. So we're not going to iterate both of them separately. We're going to iterate them together. And we have one more array, which is C, right? And the index for that is K. So all these three are initialized to 0. Okay. Now the logic is very simple. Just compare A of I and B of J. Whichever is smaller, move it to C of K. Okay. Now A of I is 12, B of J is 1. So the smaller one is 1, right? So move B of J to C of K. Okay. So now whichever element you have moved, okay, from whichever array you have moved, increase that index alone. You have not touched I, right? So you have taken element from B. So you're incrementing J. Now for every step you have to increment K, because C is going, sorry, K will be incremented every time, and then each time at the new position of K, the new element should be added. Okay. Now again do the same process. Compare A of I and B of J. So A of I is 12, B of J is 5, right? So B of J is smaller than A of I. So move B of J to C of K. So and then increment K. You have taken element from B, right? So you have to increment J. Now again do the same process. Compare A of I and B of J. So comparing A of I and B of J, we have A of I which is smaller than B of J. So you have to take A of I and put it in C of K. Increment K. And then now we have taken element from A, right? So you have to increment I. Compare A of I and B of J. A of I is smaller than B of J. So take the element from A, that is take A of I and store it in C of K. Okay, 23. Increment K. Now we take an element from A, so we have to increment I. Compare A of I and B of J, 34 and 45. A of I is smaller, so take 34, that is A of I, and store it in C of K. Increment K and increment I. Now what happens is, like IS, like traversed over the entire array A, right? No more elements in array A to be checked for. So now what happens? There are only left out elements in array B. So without even comparing, we can say that all the elements in B are greater than whatever elements are still put. And also they are sorted, right? So take all these elements one by one and store it in C of K in the next locations. Okay. So I repeat this. Since A of in array A, all the elements are traversed, no more elements to compare with. So take all the left out elements in array B and then put it in array C. Okay. So now 45, then 56. Now K also would come to the end and J also would come to the end. Now we have the sorted array. So this is what would happen for in this merge step. Okay, if we give two sorted arrays to the merge step, it will combine them into a single sorted array and give it to us. And this is the logic. Any doubts in this illustration? Okay. Now, what is the complexity of this merge step alone? Suppose there are m elements in array A and n elements in array B. What is the complexity of this merge step?
Is it m into n?
Why m into n? Any
Because we
reason?
are traversing, I mean, we are visiting every element of A and every element of B.
Yeah, only once, right?
Yeah, in A we are taking m, we have m elements.
Hmm. See,
In
these
B,
m elements are listed only once, and these
yeah.
n elements are listed only once. So the complexity should be m plus n, right?
Okay, okay.
It's not m into n, it is m plus n. Understood why it is m plus n? We're just
Yes, sir.
traversing only once through the entire array, both arrays. Okay, that's why it is m plus n. Okay, now let us see the respect to algorithm. Okay, we saw the illustration, now we'll see the algorithm. Now for this merge sort, so when did we stop? What is the stopping condition? What is the stopping condition? That is, when do we definitely know that the array is sorted?
When you have a single element.
Yes, very good. Okay, so for this merge sort, you need to pass the array, lower index, and then the higher index. And the condition is if so L is equal to K. So if L is equal to K, there is only one element, right? So we definitely know that it is sorted. So no need to perform any operation, simply return. Okay. So on a, we already know it's sorted. So that's why we are simply returning back, telling that it is sorted. Else what you have to do is, so if there are more than one element itself, immediately you have to split it. Okay. Left half and right half. So we know for splitting, we need the mid element, right? So mid is equal to L plus H divided by 2. So after getting the mid element, we need to pass the left half to the merge function, left recursive call. Again, the right half to the right recursive call. Okay. So merge sort of. So how to take the left half? A comma. What is the index of the left half elements?
L comma m minus 1.
Yeah. L comma m minus 1. And for right half?
M plus 1 comma h.
Yeah. A comma m plus 1. Not m plus 1, it is m. So if you put m plus 1,
Yes,
m
sir.
would be omitted, right? So so either you can put L comma m here and then put m plus 1 comma h, or if you put L comma m minus 1 here, you have to put m comma h. Both are correct only. Okay. So now this function, okay, will is responsible for sorting the elements between L and m minus 1. And this function is responsible for sorting elements between m and h. Okay, now we have two sorted arrays, right? Okay, inside the same array itself, we have two sorted arrays. One array is between L and m minus 1, and another array is between m and h. Now, what you have to do is you have to pass this function, so pass this array to the merge function. Along with that, you have to pass L comma m comma h, denoting that from L to m minus 1, we have a sorted array, and then from m to h, we have another sorted array. Okay, and this merge function will return us a single sorted array between L and H. That's it. So this is your merge sort function. Understood? Now, like, will you be able to write the logic for merge? So in merge, it is very simple. Okay, so you have to, you need three variables. Okay, one variable. So one iterative variable for A, one iterative variable for J, and sorry B, and then other iterative variable for C. Okay, so I will traverse through A. So here we don't have two different arrays. Only one array is there, right? Only based on the index we are splitting into two arrays. Okay, so what should I be initialized to inside the merge function? Okay, let us write the merge function as well. A comma L comma M comma H. Okay, so now what should I be initialized to? So which is the starting point for the first array?
L.
Yeah, L. And the starting point for the second array is?
M.
Yeah. And we're going to create one more array. Okay, and that let that index of that be 0 itself. Okay, and now, so let us put an infinite loop. We can use if condition to break out of this loop. Okay, now inside this loop, what we're going to do is we're going to check whether, so like what would be a stopping point of this while loop? When should we stop? See here, once we reach the end of A, we came out of the iteration, and then we saw the remaining elements of B and then stored in C, right? So that's a possibility that first B also can get over. In our case, A got over first, right? That's a possibility that B also could get over. So either I should reach the end of A or J should reach the end of B. Okay, if any one of the conditions are true, we have to break out of the loop. Now tell me the condition. If
I should be equal to M minus 1.
M minus 1 is a valid index, is the last element's index of A. This is the first array. So I should be equal to M. Okay.
Okay.
Or J is equal to
H.
H or H plus 1.
H plus 1.
Yeah. Because H is also a valid index. Okay. It is the last element. H is the last element of array B. Okay. If it crosses H, then you have to break the loop. So understood why I'm putting an OR condition? Either if this satisfies or this satisfies. If this satisfies, it means array A is over.
So, can you
Yeah.
explain this? Why you have taken M and H plus 1 once again? Because the
Okay.
last one is M minus 1 only.
Okay, fine. See, you can take this itself. So this is the first half, right? Okay. So here index is 0, 1, 2, then 3, 4, 5, 6. Right? If this was a combined array, you would have these elements. So we have the left half which is sorted and the right half is also sorted. Okay. So here, what is L plus M? Sorry, L plus H by 2. L is 0. H
3.
is 6. Okay. So 0 plus 6 by 2 is 3.
3.
So till M minus 1, this is M minus 1, right?
Okay.
And this is M. So L to m minus 1 till m minus 1 is valid. So if I reaches m, then it is invalid. Here also h is also valid. H plus 1 is invalid. That's right. Understood?
Okay. Yes.
Okay.
Thank you, sir.
So if either I reaches m or j reaches h plus 1, we're going to break this while loop. So if this condition is not satisfied, it means that both are valid indexes, valid indices. Okay, both are inside the range itself. Okay. Now what did we do here? We just compared ith element of A and jth element of B, right? So what should be the comparison and what should we do? Okay. So if A of I is less than B of J. Okay. Yeah. So here A of I is less than the same array itself, right? A of J. Same array is only partitioned into two. So A of I less than A of J. You can just create an empty list C. And then we can append it to C. Which element should be appended? Here A of I is less than C of J. Sorry, A of J.
Yeah, right.
AFI.
Yeah. So C dot append of A of I. Right? So just to keep track of how many elements are there, you can, okay, I think in Python it's not needed. Just keep on appending. We just iterate over this list and put it back to A. Okay. So why we had K is just to keep track of the number of elements in C. Okay. But in Python, we know there is length function and then we can iterate it normally itself. So no need of this K. Okay. I just comment it just for reference. You can have this. Okay. Else, what should we do?
C that append of A of J.
Yes. Okay. So here one more step we forgot to do. We should increment I.
I plus 1.
Okay. Yeah. I plus equal to 1. C dot in the else function. Okay. Append of A of J. And then here you have to increment J. Fine. So this is the like working inside the while loop. So after coming out of the while loop, there can be, so only one array would have been got over, right? Either A would have got over or B would have got over. And we're not sure how many elements are there in array A or array B. So here there were two elements left out. We took all the two elements and put it in C. But we'll not be sure how many elements are there, right? So what you do is you simply iterate over both the like without, you don't need to put any conditions because okay, I'll just write it and then I'll explain. Okay. While, so here my condition is going to be I is less than M C dot, the same thing which I've written here. Okay. Append of A of I and then I plus equal to 1. Then another while loop which would iterate over J. J less than H plus 1 C dot append, sorry, C dot append of A of J, J plus equal to 1. So why I haven't checked for any condition is that, see, suppose if A got over, okay, if suppose I reach the end of A, this condition would be false, right? It will not enter inside the first while loop at all. Okay, so that's why I didn't put any separate condition to check whether there are any elements in A or B and all. Okay, just iterate over the remaining elements. So here also, if J has got over, what would have happened? This condition would have been false. this loop would not have run, right? That's why you simply put the conditions here. So if there are still elements in A, this loop will run. If there are still elements in J, this loop will run. Sorry, in B, this loop will run. Fine. Now we have the array C, which is the sorted form of array A and array B. Right? Understood? So from L to M, okay, and then from M plus 1 to, sorry, from L to M minus 1 and M to H, we have the sorted array in C. Now what you have to do is, so having the sorted array in C doesn't help. We have to move it back to A itself. Okay. So that additional loop we have to put. So that loop will run from L to H. Okay. So I'll have one more variable. Let's say K itself. Okay. K is equal to L. Sorry, not L. Yeah, L. And then for I in C. So I'm going to iterate over the array C, that is the list C, and then move all the elements back to A, right? So I will hold each and every element of C. Now what happens? I have to store all the elements back in A, starting from index L. Yeah, I'll repeat the entire step again. Okay. Now, yeah. So A of K is equal to I, and then K plus equal to 1. So this will take back all the elements in C to A. Fine. So I'll just give an overview again. So I'll brief it again. So here, for this merge function, we are passing an array along with the indices L, M, and H, denoting that from L to M minus 1, we have a sorted array, and M to H, we have another sorted array. So two sorted arrays are there. To iterate over the first sorted array, I have I, and to iterate over the second sorted array, I have J, and I'm going to create a new array, which is C. Okay, here array means I'm just mentioning the list only. Okay, no need to worry about that. So C, I'll just talk in terms of array itself, no problem. Okay, so now we have the C array, and we're going to iterate, like we're going to create a loop, which is an infinite loop, and then check for any of these stopping conditions, terminating conditions. So the first condition means that we have processed the entire elements of array A, and this means that we have processed the entire elements of array B. Okay, so if both the arrays are like have still more elements to get processed, we'll look for this condition, which element to be appended to C. Okay, if A of I is less than A of J, I append A of I to C. Else I append A of J to C. Okay, and corresponding indices are incremented. Okay, so if any of these conditions become true, what happens? We'll break. Suppose if this condition is true, if I has reached M, which means what? We are done with array A, right? We have processed array A. So if you process array A, what happens? This condition will become false, right? Understood? Okay, so if I is equal to M, this condition is false, right? So here I checked for I less than M, which means there are no elements in array A to be processed. So this condition itself will become false, and it will come to while loop, and it will look for the remaining elements in the second array, which is array B, and then keep on appending the remaining elements to C. Fine. So I'll repeat these two steps alone. See, so in our case, what happened? For array A, we processed all the elements, and we had still two more elements which were there in array B. Okay. Okay. K was pointing to this particular position. Now here I is equal to M. Okay, and j is still not equal to h plus 1, sorry. So this is h and this is h plus 1, right? This index is h plus 1, this index is h, this index is h plus 1. Now j still didn't reach h plus 1. Got it? Okay, so this condition is true. J is still less than h plus 1. So the remaining elements, whichever are there, I'm just moving it to C. Fine. So once we are done with these two loops, okay, any of these loop only will run, okay? So once we are done with that, what happens? We have an array C which contains the sorted form of both the arrays. We have to move it back to the original array. That is what is happening in this loop. Understood? The entire process of merge plus merge sort. Okay. Yeah. Now let us talk with respect to the complexity. So recursive function, so recurrence relation. T of n. Now, so what is this condition for? What is the n value? How many elements are there in this condition?
1.
Yeah. So are we doing any operation inside this condition?
No.
No, just return. Okay. So if n is equal to 1, no operations are happening. So 0 time. Okay, we can directly say that it is sorted. So 0 time. So otherwise, we don't have any other stopping conditions, right? So directly we come to the else part. So if there are more than one element, we have to perform the merge function. So sorry, we have to call the recursive calls and then do the merge function. So now we have two recursive calls, right? So these two recursive calls will take half of elements, right? So like if time taken to solve n elements is t of n, time taken to solve n by 2 elements would be t of n by 2, right? So this array, sorry, this function takes t of n by 2 and this function takes another t of n by 2. So total
T of n.
2t of n by 2. No, not t of n. Okay, this is t of n by 2. This is t of n by 2. So 2t of n by 2.
Okay.
Okay. So 2t of n by 2 for those two recursive calls. And I have one more function call here, merge. So we already saw here, right? For merging, it will take m plus n time. Okay. So here the first half we have n by 2 elements. The second half we have another n by 2 elements. So what is m plus n here?
N.
N, yeah, n by 2 plus n by 2, which is n. So for merging, it takes n unit of time. So it is n plus 2t of n by 2. So this is a recurrence relation for merge sort. Understood? Any doubts in this? Okay,
No.
if n is equal to 1, not minus 1, n is equal to 1, 0. Otherwise, n plus 2t of n by 2. Okay, so this is at level 1. Now at level 2. So let us see what is t of n by 2. So if t of n is n plus 2t of n by 2, what is t of n by 2? So wherever there is n, just substitute n by 2.
N by 2 plus
Yeah, n by 2
twice
plus,
of n by 4.
yeah, 2t of n by 4. Okay, so n by 2, which is n by 4. Now what would happen to n to t of n? Just substitute this t of n by 2 over here. Okay, so it is, sorry, n plus 2 into, so in place of t of n by 2, I'm just putting this value, whatever we have calculated. Okay, now multiply 2 inside, we get n plus 2 into n by 2 is n plus 2 into 2t of n by 4, which is 4t of n by 4. Okay. Now, so what is the overall value? 2n plus 4t of n divided by 2, n divided by 4. This is at second level. Okay. Now at level 3, the third level. So let us find out what is t of n by 4. So substitute n by 4 over here. We will get n by 4 plus 2 t of n by 4 by 2, n by
8.
8. So now what happens to t of n? So from the previous value we are taking. So already we have 2n plus 4 into, in place of t of n by 4, I substitute this value. Now multiply 4 inside, 2n plus 4 into n by 4, which is n plus 4 into 2 is 8. So we have 8 t of n by 8. So now the overall equation becomes 3n plus 8 t of n by 8. Fine. So what would be at level 4 without calculating, can we tell?
4n plus 16 t of n by 16.
Yeah. 4n plus 16 t of n divided by 16.
T of n by 16.
Okay. Now, so what is the general form? What is at level k?
nk plus 2 power k into t of n by 2 power k.
Yeah. So it is kn plus 2 power k t of n divided by 2 power k. Fine. So in binary search itself we saw, right? So 2 power k is what? Do you see? Yeah. So here. So initially there will be 8 elements. Okay, if there are 8 elements, the first level it becomes sorry, second level becomes 4 elements. Third level 2 elements. Totally 4 elements will be there, and the fourth level. Okay. So first level, second level, third level. Okay, at level 3 it will become 8 elements. Okay. So 2 power k is nothing but n, right? So k is log n. You remember this, right?
Yes, sir.
Okay. So you can just use these values and substitute over here. So if k is the last level, so k is nothing but log n into n plus we have 2 power k t of n divided by 2 power k. So what is 2 power k? N. Okay. N t of n divided by, again you have 2 power k here. N.
1.
Yeah. So n by n is 1. So we already know that for n is equal to 1, it's not going to take any time at all. 0. Okay. So this term itself will get discarded. So overall complexity is n log n, because t of 1 is 0. Understood? So this is the complexity of merge sort. Any doubts in merge sort? Okay. Now let us go to the next divide and conquer algorithm, which is max min algorithm. So the algorithm is that you'll be given with an array. Okay, you have to find the maximum element and the minimum element. Okay, so let us take a sample array. So let us consider this array. So what is the normal way to find the maximum element and minimum element?
So we assign the first element as suppose max, and then
Yeah,
we compare it with the all the elements.
very good. Yeah. Similarly for min also, you'll do the same process, right? Mm, okay. 12, 34, 224. 5 to 6, 6. So finding the maximum, what do? We take a variable m and then store the first element. Okay, and then compare it with each rest all the other elements, right? So if we find any other element which is greater than m, we'll immediately take that and replace it with the previous m, right? So here 34 is greater than m, so 34. Sorry. Yeah, 34 becomes a new maximum. Then 2. 2 is not greater, so we can go to the next element. 24 is not greater, 5 is not greater, 56 is greater, so replace m with 56. And then 6 is not greater. So 56 would be the final maximum value. Similarly, for minimum, you do the same thing. Okay, replace the value if you find a lesser element than the temporary variable m. Okay, so what is the complexity of this algorithm? Finding maximum and finding minimum. For finding maximum, what is the complexity? We are iterating over all the elements, right? So if there are n elements, what is the complexity?
N.
Yeah, n only, right? Okay, so we are just iterating over each and every element of the array. So for maximum, it is order of n. And for minimum, for finding minimum, it is also order of n.
Same.
Yeah. So what is the total complexity?
2n.
Yeah. So it is order of 2n. Okay. So the overall order might be n, but we're going to consider 2 also. Why? Because we're going to compare with an algorithm which is going to give the same order. Okay. I told you, right? When the coefficients should be included. If you are doing a comparison between two algorithms which has the same order. So the other algorithm is also going to be order of n. Okay. So if two order of n algorithms need to be compared, we have to consider the coefficients also. So for the normal max-min search, okay, we have order of 2n. Now let us see the divide and conquer strategy, and then let us see whether the complexity is being reduced or not. Okay, so now the objective of max-min algorithm is that, so if you give me the entire set of array, I will not be able to find out the maximum and the minimum. Instead, give me a single element array or a two element array. Okay, I would do the calculation and give you the maximum and minimum. So that is the principle of maximum algorithm. I repeat again. If you give the entire array, I will not be able to find the maximum minimum. Instead, give me a single element array or a 2-element array. I would find out the maximum and give it to you. Okay. So if it's a single element array, so which is maximum, which is minimum?
The element itself.
Yeah. So there's only one element, so that is the maximum, that is the minimum. So the element itself be the maximum and minimum. So if it's a 2-element array,
Compare.
yeah. So with one comparison, we'll be able to tell, right? So the greater value would be the maximum and the lesser value would be the minimum. That's it. Now let us see the illustration and then we'll go to the algorithm. Okay. So now, so there are more than 2 elements. Okay. I can solve it only if I have one element or 2 element. So what I have to do? I have to split it. Left half
So if
and
it's one element, then we can say that it has match sort now.
sorry, one element.
If one element, if we divide like this, then we can say that it is a match sort now.
No, this is a different strategy. We are not going to apply merge function here.
Okay.
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 Okay, I'll tell you.
Same principle but different process.
Splitting is same, but the combining is different. There merging is different. Here
Okay.
merging is different. Okay.
Okay.
So here, still this is not solvable because there are more than 2 elements. Okay. So it will get split into 12 one side, 34 2 on the other side. Now what happens here? We have 12, which is a single element array. So this function would return maximum and minimum from this side, right? So from here, maximum is 12, minimum is also 12. Okay. Now this, with respect to left recursive call, I have one maximum and one minimum. Now it comes to the right recursive call. So now there are 2 elements. Comparing these both, we can find out which is maximum and which is minimum. So here maximum is 34 and minimum is 2. So this would return maximum is 34 and minimum is 2 to the previous function. And this function has 2 maximums and 2 minimums. Okay. So to find the overall maximum, just compare the 2 maximums. To find the overall minimum, compare the 2 minimums. Okay. So now we have the overall maximum, which is maximum of maximum. Okay. Among 12 and 34, the maximum value is 34. And the overall minimum is 2.
Minimum of 12 and 2.
Yeah. Minimum of both the minimums, which is answer is 2. Now this maximum minimum would be returned to the previous function call. Now from here it comes to the right recursive call. This is still not solvable. So split it. Okay. So here maximum is 24. Minimum is 5. So this maximum minimum will be returned to the previous function call. And now comes to the right recursive call. Maximum is 56. Minimum is 6. And this would return 56 and 6 to the previous function call. Now I have 2 maximums and 2 minimums. So the overall maximum is 56 and overall minimum is 6. Now this function,
5.
sorry, 5. So this function has 2 maximum values, 34 and 56, and 2 minimum values, 2 and 5. Okay. So overall maximum is 56 and overall minimum is 2. So this is how the combining is happening. So we're not applying the merge function, which was the same as in merge sort, right? This is a different merging. just considering only two elements of each level and then combining them. Okay. So this is the like illustration of Max-Min algorithm. Any doubts on this?
No, sir.
Okay. Now let us go to the implementation. So Max-Min, we have the array, lower index and higher index. Now here, so when did we stop? There are two stopping conditions, right? If number of elements is 1 and number of elements is 2. First, let us consider the first thing. And this would return like maximum and minimum. Okay, let us see like how it is happening. Now, like if there is only one element, this if L is equal to H, so what should we do? So let us consider the function is going to return two values, okay, as a list or a tuple, whatever is fine. So first value corresponds to maximum and second value corresponds to minimum. So return, I need to pass two values, maximum and minimum. Okay, there is actually only one value here, right? Only one element. So for both the locations, both the places, I have to pass the same value. So which is nothing but A of L, comma, A of L. Understood this now? The first value corresponds to maximum, second value corresponds to minimum. So here maximum, minimum both are same. So I'm passing the same values. Now I have, if I have two elements. So what is the condition to check whether there are only two elements? What is the condition?
Length.
No. Not length. Just put index, you have to tell me.
There
L
should
plus
be
1
only
is equal
two
to
index.
Comparing the index itself, we can tell how many elements are there.
L plus 1 is equal to H.
Yeah. L and H should be adjacent, right? So if L plus
Yeah.
1 is equal to H. Understood? So L plus 1, if it is equal to H, then there are only two elements. Now we have to make a comparison between the two elements. Okay. So if A of L is greater than A of H. So what should we return?
A of L, comma A of H.
Yeah. So first element corresponds to maximum element and second element corresponds to minimum element. So pass A of L, comma A of H. Else, what should we return?
A of H, comma A of L.
Yeah. A of H, comma A of L. So this is for two element array. Else, what should we do?
M is equal to L plus H by 2.
Yeah. First you have to find the mid element, which is nothing but L plus H by 2. And then you will have left recursive call and right recursive call. Left recursive call will return a list. Again, right recursive call will return one more list. Okay, I'll write L1, which is list 1, is equal to max-min of. So what should I pass to the left recursive call? A, comma, the same as in merge sort. Okay, L, comma, M minus 1.
M minus 1.
And then L2 is equal to
M. Oh.
mm of A, comma, M,
comma
H.
H.
Yeah. Now this L1 contains max and minimum at index 0 and index 1. This L2 contains max and minimum at index 0 and index 1, all with respect to these elements itself. Right? Now I have to find the overall maximum and overall minimum and then return that value. Okay. So return, can write it in single step itself. Max of what? L1 of 0, comma, L2 of 0, comma, min of L1 of 1, comma L2 of 1. Understood this? Any doubts? You are finding maximum among the maximum. You know, maximum is present at the 0th index, right? So L1 of 0 and L2 of 0 are the maximum values. L1 of 1 and L2 of 1 are minimum values. Okay? So this will give the maximum among maximum, and this will give the minimum among minimum. Just create a list and then return it. Fine. Now let us see the complexity. So for that, we need to write the recurrence relation. So this is quite tricky. Okay. Here. Uh, 1 second. Yeah. So here, like, can you repeat L1 and L2 again? Okay. So I'll repeat this last 3 steps. Okay. So here, like, L1. See, what is this? What is this maximum left recursive call? See, this is the overall. This is the first function. So from here, it is calling the left recursive call and the right recursive call. Okay, and the first function corresponds to the left recursive call. And we can see that this function is returning a list which contains maximum at 0th index, minimum at first index. That is what we are storing it in L1. This is returning some value, right? That we are storing in L1. And that is nothing but the maximum and minimum. Are you able to follow?
So, but it is having more than 2 elements, no?
Yeah, as a list only, no? See, I'm
List.
passing it as a list only.
Yeah. Okay. Yeah, got
Okay.
it, got it.
So L1 is a list, L2 is another list. 2 lists are there. From this list only, I'm taking the 0th element, which is a maximum value. And from the second list, I'm taking the 0th element, which is the maximum value of the second half. Compare two maximums, overall maximum would be the final maximum. Similarly for minimum. Understood?
Yes, sir.
Okay. So now for so it's just simple return, right? So for return, you're not going to consider any time. So if number of elements is equal to 1, the time taken is 0. Fine. So if number of elements is 2, we are having one condition just to be evaluated, right? Okay. So for that, we'll take one time unit. For n is equal to 2. Do you understand this? Okay, we are doing a comparison, right? For that comparison, we are taking one time unit. And if there are more elements, okay, so we are performing we are performing maximum on both the sets, right? Left half as well as the right half. So left half, it will take, so if overall element is taking t of n, left half means it will take t of n by 2, right? So t of n by 2, t of n by 2. So 2 t of n by 2. The same thing as in merge sort, okay? And then plus, here we are finding out the maximum among maximum and minimum among minimum. So for finding out maximum, we'll take one time unit. And for finding minimum, we'll take one more time unit. So 2 time units are there. Are you able to get it? For finding maximum, we'll take one time unit. And for finding minimum, we'll take another time unit. So plus 2. You understood why I'm putting 2 here? For finding maximum and minimum. Okay. So I'll just move it to the front. So it is 2 plus 2t of n by 2 plus 2t of n by 2. Yeah. And this is the otherwise case. Any doubts in this recurrence relation?
No, sir.
Okay. Now let us find out the complexity. So this is at level 1. So what is at level 2? So what is t of n by 2? Substitute n by 2 in this equation, you get 2 plus,
Twice of Tn by 4.
yeah, twice of Tn by 4. So t of n is equal to 2 plus 2 into, in place of t of n by 2, I'm substituting this. Now if you multiply 2 inside, we get 2 plus, this 2 is for this one, okay? And then 2 into 2 is 4 plus, again 2 into 2t of n by 4, which is 4t of n by 4. Now I'm not going to simplify this because it will lead to a series that can be taken a form. Okay, a formula is there for that series. That's why I'm not going to combine these two terms. Let it be 2 plus 4 itself. Now let us see what happens in the next step. Level 3. So we have t of n by 4 here. So what is t of n by 4 is equal to, just substitute n by 4 over here. We'll get 2 plus 2 t of n by 8. Okay. So t of n is equal to 2 plus 4 plus 4 into, substitute this value in place of t of n by 4. Okay, I'm considering this and then substituting t of n, this value in place of t of n by 4. Now multiply 4 inside. What will you get? 2 plus 4, which is from the previous value, plus 8, right? Plus 4 2s are 8. 8 t of n by 8. Okay, so now can you tell me what would be at level 4 t of n?
Two
Yes.
plus 4 plus 8 plus 16 plus 16 t by n by 16.
Yeah, very good. 16 plus 16 t of n by 16. So what is that level k? Yes, till which point it will go? 2 power k, right?
Yes.
Yes, it will go till 2 power k. So 2 plus 4 plus 8 plus, it goes on till 2 to the power k. Okay, and then plus 2 to the power k t of n divided by 2 to the power k. Any doubts in this? Understood, right?
Yes, sir.
Okay. Now we have a series over here. So let us find the short form for this series. Okay. We are not going to derive the series. We have a straight away formula, which is nothing but 2 to the power, sorry, 2 to the power k plus 1 minus 2. Okay. So just to check this, we'll just evaluate for one value of k. Okay. So for k is equal to 4. So like what is LHS? 2 plus 4 plus 8 plus 16, right?
16.
So what is this is equal to? What is the total value? Total
30.
30. Yeah. So what is 2 power k plus 1? What is 2 power 5?
32.
Yes. So and 32 minus 2 will give you 30. Fine. So just evaluating whether this formula is correct. That's it. So we can just simplify this entire series into this one. So just substitute this over here. What would happen to t of n? Equal to 2 power k plus 1 minus 2 plus this one. Understood? So this form has been converted to this form, substituting the series value. Now, fine. So let us assume k as the last level. Okay. So in Max-Min algorithm, are we going to reach the last level? No, right? Why? Because we have the solution at n equal to 2 itself. Okay. We have a solution at n equal to 2 itself. If number of elements is 2 itself, we have a solution. So we need not go till the last level, which will take us to the individual elements. So you can stop at this level itself. Okay, understood? So we're not going to the kth level, whereas we're going to stop at the k minus 1th level itself, assuming kth level is the last level. You understood why we are stopping at k minus 1th level?
Yes, sir.
Okay.
Yes, sir.
Yeah. So what is it at level k minus 1? What is t of n? So in all these places, just substitute k minus 1 in place of k. So 2 to the power,
K.
yeah, k and minus 2 plus 2 to the power,
K minus 1.
yeah, k minus 1 t of,
N by 2 to the power K minus 1.
yeah, n by 2 to the power k minus 1. Okay. So we already know that 2 to the power k is equal to n. So what is 2 power k minus 1?
N minus 1.
No.
N minus, sorry. No.
1 plus log n. 2 plus log n or 1 plus log n.
Why? See, 2 per k is n. What is 2 per?
Because we need to shift log. It becomes, yeah.
No logs.
Yes, sir. K minus 1 becomes log n. No log. Okay.
See, I'm asking what is 2 per k minus 1. I'm not asking what is k minus 1. K is log n. That is fine. K minus 1 will be log n minus 1. I'm asking what is 2 per k minus 1 because there is no k terms at all separately, right? We have only 2 per k term and k 2 per k and 2 per k minus 1 term. So what is 2 per k minus 1?
Is it n minus 2?
No.
N plus
See,
1.
you are reducing by 1 power of 2.
K over 2, 2, 2.
Okay, see, very simple. See, 2 power, let us assume k is 5.
Divided by 2.
Yeah, correct. So it is n divided by 2. So 2 per k is, so suppose if 2 per 5 is 32. What is 2 per 4? 16, right? Divide by 2. So n by 2. Understood? So if 2 per k is n, 2 per k minus 1 is n by 2. So just substitute these two values over here. We have only these two terms here, right? So t of n is equal to, in place of 2 per k, put n minus 2 plus 2 power k. Sorry, 2 power k minus 1. So we have n by 2. T of n divided by n by 2. So what is n divided by n by 2?
2.
Yeah, very good. So understood? So 2t of n divided by n by 2 will give 2. So what is t of 2?
1.
1. So it is nothing but n minus 2 plus n by 2. So in place of t of 2, I'm substituting 1. So it will get, okay, this will become 1, right? So 1 into n by 2 is n by 2 only. So here you have n and you have n by 2. So it is equal to 3n by 2. And minus 2 can be omitted, right? Because it's a very small term. So overall complexity is 3n divided by 2. Okay, so the normal algorithm produced 2n, whereas Maxman algorithm using divide and conquer is producing 3n by 2. For the normal algorithm, it was 2n. So which is better?
Maximum.
Yeah, using divide and conquer is better, right? So because 25% of the time has been reduced. Okay, fine. So next algorithm which we are going to see is Quicksort. So Quicksort is an interesting algorithm. We'll take the same set of elements. So in Quicksort, what would happen is we would be taking a pivot element. Okay, so pivot element means it's nothing but it is going to like uh, so in insertion, what did we insertion sort? What did we do? We took an element and then we had a sorted array. We took an element and then inserted it at the corresponding location, right? Okay, so that element which you are picking is called pivot element. In Quicksort also, we'll be picking an element and we'll be moving all the elements which are less than the pivot element to the left hand side and all the elements which are greater than the pivot element to the right hand side. Okay, that is your Quicksort like overall logic. And the left hand side, I told all the elements will be less than the pivot element, right? It need not be sorted. Okay, only thing is all the elements should be less than the pivot element. And in the right side, all the elements should be greater than the pivot element. And we'll be recursively applying this algorithm. Okay, so this is the overall concept. Now let us try to understand with an example. Okay, so let us take a different set of elements. 10, 80, 30, 90, 40, 50, 70. Okay. So the first thing which you're going to do is you're going to choose the pivot element. Okay. For choosing the pivot element, you can do any of these steps. One is choosing the first element or as the pivot element, or choosing the last element as a pivot element, or choosing any random element as pivot element, or you can also choose the median element as the pivot element. Okay, so here choosing the random element and choosing the median element are going to take some additional time. So because you have to apply some random function or in median you have to calculate the median. So we are not going to take these two. either we will take the first element as a pivot element or the last element as a pivot element. Understood? So now let us see by taking the last element as a pivot element and how the algorithm is working. Okay, fine. So now let us take the last element as a pivot element, and we have low, we have high, so indices are 0, 4, 5, 6, and so what is the pivot element? This is the last element, which is nothing but, let us suppose this list is A. So A
Yeah.
of H is the pivot element, and the value is 70. Okay. Now we'll take two indices. Okay. So one index I, which is going to like represent where the pivot element has to sit. Okay, we'll be iterating over this entire list, and you have to find out the location where the pivot element is going to sit. And we'll be having one iterative variable j, which would iterate over this entire list. Okay, not the entire list, we'll be leaving the last element because this has been taken as a pivot element, right? So till L to H minus 1, j would be iterating. And I is going to represent where the pivot element is going to sit after the end of the iteration. And simultaneously, what we'll be doing is we'll be grouping all the smaller elements together and the larger elements together. Okay, smaller elements means elements which are less than h, sorry, elements which are less than p, and larger elements means elements which are greater than p. So all these things will happen simultaneously. Okay. So now we will initialize I as the lower index value minus 1. Okay. So which is L is 0. So initially it is minus 1. And J is the starting position of the list, which is L. Okay. Don't initialize it to 0 because all the time it may not be 0. Okay. If it is the right hand side half, then the L value would be different, right? So initialize J as L. Now we'll see it step by step. So there are two conditions, right? So one is if the pivot element is greater than the jth element, or the pivot element is less than the jth element. Okay. So if the pivot element is greater than the jth element, now what you would do is you would increment I. Okay. Why? Because you have found out an element which is less than the pivot element, right? So you have to increase the pivot position. That is the i's position, which is going to represent the index where pivot is going to sit, right? So that's why we are incrementing I. And after doing that, okay, you just swap A of ith element and A of jth element. Okay.
So
Now
one
both,
explain why. So,
yeah, we'll just see the illustration and then I'll repeat it again.
okay.
Now what happens is A of I and A of j both are pointing to the same location after increment of I, right? So initially I was minus 1. After incrementing I, so here is this connection true? First of all, P is 70 and j is 0, L is 0, right? So j is 0. So P greater than A of j, 70 greater than 10. Condition is true. So what happens? I would get incremented, and then I is 0, j is also 0. Okay. So swapping A of I and A of j is not going to give any change in the array. So it will be the same list only.
So
Okay. Yeah.
I can you explain this one, that why have you kept I equal to minus 1? Because we have chosen the pivot element as 70, and you said that initially I should be pointing to the pivot element.
No.
So
I told that I I is not pointing to the pivot element. After the end of the iteration, I would be like the index where the pivot element has to be stored.
Okay.
Okay, after the end of this iteration, so I should find a location where the pivot should be swapped, right? See, some elements would be lesser, some elements would be greater,
Yes,
right?
sir. Yes,
So
sir.
70 should be moved somewhere in between, right? Moving all the larger elements to the right hand side.
Yes, yes, yes.
That is what is I.
Okay.
Okay.
Okay, thank you.
So swap A of I and A of J. So I and J both are pointing to the same location, so no change in the array. And else part will be nothing. Okay, no need to perform any operation if P is less than A of J. Just increment J, that's all. That would happen in the iteration step itself. Okay, so once you come out of this array, once you come out of this entire iteration, what happens is just this I would be representing the last value of the smallest uh, okay, the last value of the smaller elements which are less than elements which are less than pivot. Okay, so I'll illustrate and then it will be clear to you. So after end of the iteration, what you have to do is swap I plus 1th element, that is swap A of I plus 1 and the pivot position. Okay, don't swap P, swap P of H, sorry, A of H. Okay, if you swap P, then only the temporary variable will get swapped. Whereas I want to swap the original array itself. Array elements need to be swapped. Okay, so now let us see the illustration, then it will be better. Okay, so if L is equal to 0, H is equal to 6, 0, 1, 2, 3, 4, 5, 6. Yeah. And then P is equal to, suppose this array list is A of H, which is equal to 70. And then what are we initializing I and J as? I is equal to L minus 1, which is equal to minus 1. And then J is equal to L. Okay, and J would iterate from L to H minus 1. Okay, only till 50, not till 70. Okay. So the first value of J is what? 0. Now let us see what is happening step by step. So if J is 0, what was the condition? If, so here is, you have the condition, right? P greater than A of J. Okay, so what is P? 70 greater than A of J, 10. The condition is true. So now what should we do? Increment I and then swap A of I and A of J. So, which means I is equal to 0, sorry, 0. And then swap, I'll just write the elements itself here. So 10, comma 10, right? So I and J both are same and both are pointing to 0 only. So swap 10 and 10. So no change. The final array itself would be the same. I'll just write it. So if there is any change, I'll just write it over here. Now the second iteration, J is equal to 1. If pivot element is 70 greater than, what is J of A of J? Here, 80, right? 70 greater than 80. So condition is false, right? So now it will go to the next iteration. There is no else part. So it will go to the next iteration. J is equal to 2. So it is 30, right? So if 70 greater than 30, condition is true. So what happens? I plus equal to 1. So I is equal to 1. Swap A of I and A of j. What is A of I? 80. And j is what? Second location, just 30. So now what would happen to array?
10, 30, 80.
Yeah. 10, 30, 80, 90, 40, 50 and 70. Okay, now this is a new array after swapping. Now next value of j is 3. So at third location we have 90, right? So if 70 greater than 90, condition is true. So I plus equal to 1, which makes I as
Sir, I is, 70 less than 90.
oh, sorry. False. Okay. So now next iteration. So that's my else part, right? So next iteration. If so I is equal to 4, 40, right? So 70 greater than 40. Condition is true. So I plus equal to 1, which makes I as 2, right? Okay, and then swap A of I is what? I of I is pointing to second location. In this array, second location is 80,
80.
comma A of j,
40.
fourth location is 40. So after swapping 80 and 40, we have the array as 10, 30, 40, 90,
90, 80.
80, 50, 70. Now next value of j, which is 5. So fifth element, that is element, element at index 5 is 50, right? So if 70 greater than 50, condition is true. So I plus equal to 1, which makes I as 3. Can you see the elements are getting grouped, smaller elements? So now swap of A of 3. A of 3 is what? 90 and then 50. A of j is 50. So after swapping, you get the array as 10, 30, 40, 50, 80, 90, and then 70. Now a loop is over, right? It has reached h minus 1. J has reached h minus 1. So the loop is over. So after coming out of the loop, so can you see I is pointing to third location. So till this point, all the elements are lesser than pivot element, right? So now what I would do is the I plus 1th location will be swapped with the last element, which was the pivot element, right? Now what happens? If we swap these both, all the elements in the right hand side would become greater than pivot element, and all the elements which are less than, in the left hand side become less than the pivot element. So after the end of the iteration, swap A of I and A of I plus 1 and A of H. Okay, don't forget this A of H. Don't put P here, it will not work correctly. So P is a temporary variable which you have taken. Okay. So we have to swap with the element present inside the array. So now what happens to the A? Go to 10, 30, 40, 50, 70, 90, 80. So all the elements in the left hand side of the pivot element are less than, and all the elements right hand side are greater than pivot element. and not necessarily they will be sorted. Okay. Now what we have to do, we have to again apply the sorting algorithm for quicksort for this set of element, and the sorting algorithm for this set of element. Recursively you have to do. Understood? So this is a uh, single partitioning algorithm. Understood, right? How this is working? Okay. So now let's quickly see the algorithm also. So the algorithm looks pretty very simple. Okay. Quicksort A comma L comma H. Okay. So now like so there is a possibility that there can be zero elements also, right? Zero elements, when will that zero elements happen? If we choose a pivot element which is the largest element, all the elements okay would be accumulated in the left hand side. Right hand side there will not be any elements at all if the pivot element is the largest value. Got it? So there are scenarios where there can be zero elements also. So we have to consider that scenario as well. And if there is only one element, do we need to do any processing?
No.
No, right? One element means it's already sorted. We can simply return. Okay. So we can combine those two conditions and write it over here itself. If L is greater than or equal to H. Do you understand this? If L overlaps or if it is equal to H, if there is only one element, don't do any operation, just simply return. Okay. Else. Now we have to, okay. So like this is a pivot algorithm, right? Whatever you have seen is a pivot algorithm. And in this pivot algorithm, what all things are happening? Grouping is happening. Smaller elements are grouped together and larger elements are grouped together. And we have the pivot element has come to its position where it has to sit, right? Now, what this pivot element should return is, it should return where we have placed the um, that pivot element. Then only what we can do, we can pass the left elements to the recursive call, left recursive call, the right elements to the right recursive call. Okay. So now we're going to call the partition element, and that is going to return an index, which is the pivot index. Pi is pivot index, and we call the partition algorithm by passing a comma l comma h. Right. So in this partition algorithm itself, you have the grouping happening as well as the pivot index returned. We will quickly see the partition algorithm also. Now what you have to do? We have found the pivot index. So this is the pivot index. Now we have to pass these elements to the left recursive call and these elements to the right recursive call. How to do that? Tell me. Keywords of a comma. Yes. What is the index of the left array?
L
L comma.
P minus 1. Pi minus 1.
Correct. Pi minus 1. So this is the Pi is the index of 70. So I have to consider all the elements before 70. So Pi minus 1. Okay. And quick sort of A comma.
Pi plus 1.
Yeah. Pi plus 1.
Comma
Comma H. Okay. That's all. This is your quicksort algorithm. Okay. So now coming to the partition. So partition is going to return a index. Okay. It will group and then it will return the index. So that index is an integer value, and for partition we are going to pass the array lower index and the higher index. Okay, so now let us do it step by step. What are the first thing that we did? Yes,
Chose the pivot element.
Taking
yeah, we are choosing the pivot element. So P is equal to A of H. Now, so what should I be initialized to?
L minus 1.
Yeah, very good. L minus 1. And J is equal to
L
L.
minus 1.
No, no, L.
L.
And
Starting L.
J is equal to L.
And we can write a while loop for iterating this J. Okay. So what is the condition? Till which position J can iterate? J less than
H.
H. Okay. Till H minus 1 it can go. That's why you put J less than H. Okay. Now, what should we do inside this while loop? We had only one condition, right? If
P is greater than
yeah, P is greater than A
A
of
of J.
J,
And
increment I first.
increment I and swap.
Yeah.
And then swap.
Swap of A of I have both the same only, right? A of I comma A of J. So here you have to write the logic, okay? There is no function to swap and all. So you have to write the logic here. And then we have to increment J. Right? This comes out of the if condition, okay? Don't put it inside the if condition. This is out of the if condition. So once this loop is done, what you have to do finally? Swap
I plus J. I
Yeah.
plus H. And
A of I plus 1 and A of H. And then finally return I plus 1, okay, which is the index of the pivot element. So you swapped the pivot element to the I plus 1th location. So that is the pivot index, right? I plus 1. That's it. So this should be returned over here.
So that if L greater than is equal to H, then return 1. Or
No, I didn't get you. Which one?
in quicksort, if condition. After if condition, what should be written?
Which if condition?
Quicksort function.
Here.
What?
No, simply return.
Okay.
It is quicksort is a void function, okay? It's not going to return any values. Partition is only going to return an integer value, which is an index. Okay. This is an empty return. Okay. That's it. Any doubts?
No, sir.
Okay. So there is actually one more algorithm finding the median of two sorted arrays. Okay. That we can see in the next class. Okay. So shall we wind up?
So,
Yeah.
Sir, in earlier classes, you have explained one logic that to find whether a number is a power of 2 or not.
Yeah.
So the normal logic which you told, that was simply divide by 2 and check.
Yeah.
And the other one was the bitwise operation.
Yeah.
So first one is fine, but I'm not able to code for bitwise operation.
No, it is very simple. If
So
n
and you have given n and n minus 1 should be equal to 0. So but this like n should be a binary code for the number, no?
No, this is bitwise operation, right? It will
Yes.
automatically consider as a binary value as a binary value only.
Okay, so we
You
need
you
not
need
convert this.
no
Okay.
you should not convert. See, for all binary operations, you will be giving the normal value only, right? Integer only, right? You're not going to
Okay.
convert it to binary and all.
Okay.
Okay.
Okay. Thank you.
Yeah. Okay. Fine. So thank you all. We can meet in the next class.
Thank you, sir.